We're preparing to work with vectors. Vectors have angles. Angles have to be measured with respect to something. They can be airplane angles. They can be calculator angles. Here are airplane angles discussed, or examples are shown for all possible airplane angles. If the airplane direction is between north and east, then we say that's a northeast angle measured from the north. If the airplane angle is between north and west, we call that northwest angle measured from the north. Measured from the north in both cases. If the airplane angle is between the south and the east, then we call that a southeast angle measured from the south. If the angle is between the south and the west, we call that a southwest angle, again measured from the south. All airplane angles are between 0 and 90 degrees positive, never any other possibilities. That covers all possible angles. Those are airplane angles. Calculator angles are different. We have two coordinate systems, an x and a y coordinate system and a real and imaginary coordinate system. They're identical, just going by different names. In both cases, angles are measured from the horizontal axis, whether it's the x-axis or the real axis, it doesn't matter. Positive if the angle is counterclockwise. Negative if the angle is clockwise. Minus 180 degrees to plus 180 degrees captures all possible angles. Overlapping is possible. The calculator knows how to deal with that, but the calculator result will always be between minus 180 and plus 180. You can enter an angle outside that range, and the calculator knows how to deal with that appropriately. The calculator has several useful functions for mechanical engineers, namely cross product and dot product, that deal with the vectors in the XY coordinate systems. Most of the calculator functions are relative to complex numbers that have real parts and an imaginary part. They're identical concepts with different names. So this has been angle references measured with respect to airplanes and measured with respect to calculators.